This is 4.8. How do you tell whether a correlation exists between paired data? In this lesson, we're going to show you how that works. The strength of correlation is R, what we call a correlation coefficient. Here's what I want you to watch. I'll show you how to calculate R. But when R is -1, it means that the points are close to the line and that it's a negative slope. When R is 0, there's no points close to the line. It's not correlating at all. There's no correlation when R is 0. When R is 1, the points are close to the line and there's a positive slope. So keep that in your notes. That will help you. And now I'll show you a scatter plot. This is where we look at correlation. Here is an example of R equaling 1. Okay? There's positive slope that's going up to the right, as I taught you before, and the points are real close to this line that you've chosen as a best fit line. The points are just right on that. So the R would be 1. An example of R being -1 is if you have a scatter plot and the line is going up to the left, it's a negative slope, but the points are still real close to it. That would be a -1. Now, if you have a situation where the points aren't real close, but there's still that trend to the positive, then it would be like a 0.5. It would be closer to 0.5 than to 1. And that would be positive because it's positive slope. When it's going up to the left and they're not real close, be close to a -0.5. Okay? What's a 0? No correlation at all. The points are everywhere. You couldn't even fit a line to it. You will be given data to estimate a correlation coefficient. Once you have graphed the data, if you ask, you can check your work on a graphing calculator, and I'll show you how to do that in class. Okay, it's not hard at all. But that way you can check and see if you've kind of got an idea down pretty well. Correlation is a relationship that exists between one variable and another, but it does not necessarily mean that one causes another. Okay? For example, we might have summer temps. And latitude. We might graph that and see what happens there. We might graph price of gasoline and number of cars on the road. Okay, these are just combinations of things that we might be curious to look at, see if one affects another, if there is a correlation or a relationship. Okay? Now, there was a study that scientists did on this little piece in your brain that's called an amygdala. Anyway, it's a tiny little nodule in your brain, and what they found is that people that had larger social circles ended up that when they did the brain scan, they had a larger amygdala. But then they started to wonder, well, did they have the larger amygdala before they had the social circle and one caused the other? Or does having the larger social circle cause the plasticity of your brain to increase the size of the amygdala? So that would be probably a good question for me to have on a test and to see you argue it out as to whether or not you think that there's a correlation there or whether there's a causation. Because that's a really critical one that you can kind of reason out, well, it could be this way or that way. Okay, but get your own words and thoughts going together for that, because that's a great test question.